My name is Shaun, and I'm guessing I'm doing our very first soccer analytics project. This is also my very first analytics project, so I kind of just wanted to focus on a sport that I love, and that's soccer. And for me, by far the most exciting part of soccer as a sport is the fact that it's unpredictable. There's like a million possibilities, and really the outcome of the game is so simple. You need to score more goals than your opponent, but there's so many different ways in which it can happen. So trying to find some kind of structure within this chaos of possibilities is basically what I was trying to do. I wanted to model attacking sequence in soccer to see if there's factors which basically tell us if there's certain things you should be doing to make the quality of your shots higher. So what constitutes a great chance in soccer? So let me ask you a question. Is there any Arsenal supporter here, any Arsenal fan here? So if you ask him, his answer is probably going to be that a good set piece is what makes a great chance in soccer, because that's how most Arsenal fans play. This doesn't have anything to do with me being a Chelsea fan, but I think this is evil. Watching set pieces is like watching paint dry. I think it's boring, and if you had a game full of set pieces, you would probably fall asleep. I think the best way to, and the most exciting way to create a chance and also to enjoy the game is really through open play. Something like this. Something like that to me is just beautiful. No matter if you're a beginner to the sport, just watching it, the crisp passes as they cut to the defense, just one uninterrupted sequence all the way to a goal. I think that's the beauty of soccer, and that's what I wanted to model. So I settled on my research question, which is what is the impact of transitional phase factors, which is really just a fancy way of saying how do the number of passes, the duration of an attack, the position of an attack, how do these factors affect shot quality in soccer? So shot quality in soccer is measured using XG, which is basically a prediction of the percentage of whether this shot that I've taken would end up in the goal. But before we even go there and try to find the SG, there's a problem. Soccer, as I mentioned, is chaotic and fluid. There's a million factors. So how are we going to find the data that we need, which is for every single attacking play, which results in a shot? And how are we going to understand what that data means? So for this, I basically decided to use StatsBomb. Soccer data is kind of hard to get because a lot of it's summarized for after game facts, or it's the other type of data, which is really scary, which is event level data. This is basically data which is down to the event. Every single foul, every single run, every single pass, every single interception. All of this data is basically just sourced into one, from where you can basically use the minute details to essentially create the data that you need to analyze. So I used StatsBomb, which had about a 34 sample size of games from the La Liga 2017-2018 season. And as you can see, the events I had were about 120 events that I basically needed to filter through. So I wasn't going to do this manually. I would have probably lost my mind. So what I ended up doing was I used Snowflake to build a database, transform my data using some CTEs, which are just fancy SQL functions, to change the granularity of my data to get it to a point where I could analyze it in pandas. So the end goal is basically, the end result is basically this analytical grain where we get one row per successful shot of a transition. And you'll have things like the location of the shot, the XG of the shot, the possession duration, how long it was, as well as the number of passes and the length of the pass. Now, there's a lot more factors which could go into it, but this is what I was able to do with the skills that I had. Now, coming back to a transition, we basically want to define it as an instance where a controlled possession is moving into a final third, resulting in a shot. That's what we want to look at, because we're trying to find a relationship between successful shots. Now, when we analyze that initial data that we got from that granularity, after granularizing our data, we basically see this. What does this tell us? You have three different states of the game, which is when a team is winning, when they're trailing, or when they're tied. Across all of these, you notice that in general, faster transitions have only a weak effect on shot quality. This is interesting because generally you'd assume that the faster a team plays, the faster they get into the final third and shoot, the better the shot quality would be. But slow transitions actually, in fact, especially when you're trailing right here, you actually see the slower shots have much better shot quality than the faster transition paced ones. So faster does not equal better. Now, with this insight, I think I wanted to model this and see if there is actually any veracity to it. Is this true? So I decided to use machine learning to basically build a function which is giving us an XG based on a function of pass length, duration, passes, and game state. So we decide to use, we basically first decide to split our data set into a training and test data set because there's not a lot of data available, so I had to be conservative with what I had. And we decided to train our trees using, we decided to train our model using decision trees. Decision trees are basically an ML model which give you a lot of inference. They allow you to dive into your model and say how your predictors, how your variables are actually affecting your response variables. So there's 3 different types which have their own caveats. Some are randomized, some build their model slower. But the end goal is really inference. We want to be able to tell why our predictors do what they do. But to train and fit these trees, I have a very small sample size, about like 1,000 data points when I reduce the granularity. So I need to train this on multiple data sets. So I need to cross-validate my models and test them again and again in order to increase reliability. So a whole lot of math later, just like Roberto Carlos's kick during that one World Cup event, I ended up with the following results from my models. The thing you notice here right off the bat is that all of these models right here have a load test and CVRSME, which is really just a fancy way of saying that these models are highly accurate and they're not overfitting our data. This is a good thing. This means that our models are actually working. They're actually making sense of the data. The other thing you also notice is that all of them tend to have similar, I guess, performance levels. This is interesting because usually you would notice a difference between them. You would expect the gradient boosting to be much more performant than, say, the base model of a decision tree, but we don't see this, mainly because it seems that we've kind of hit the ceiling of how we can model this data. So the only way to improve this is to add more predictors into the model. But the most important thing of all is that it's not speed, it's not game state, it's not pass the duration of the play, it's the length of the pass, which is the most significant feature predicting the outcome of a shot. So what does this all mean, right? You have a bunch of jargon, you have a bunch of math. Basically, we can boil it down to 2 sides, right? One is pass length is basically the factor which determines shot quality. So when you think of a possession-based team like Manchester City, they have a slow build-up play, but when they get into the final third, they make quick, direct in specific patterns which allow them to unlock defenses and make and score goals. Whereas when you think about a counter-attacking team, like say prime Real Madrid, they succeed also through direct passes, but these are passes which are in transitional pace all the way from the opponent's half, and they're made through balls, slicing defenses, and making sure that they are picture perfect. The tactical insights you can get from analyzing data like this is basically enabling your stakeholders to strategize and refine their tactical adjustments during the game. We know that speed doesn't generally improve our outcomes alone, so we need to prioritize the research of direct and progressive passing inside the game. And we also see that despite what you might think, game state, which is the fact, are you winning, are you losing, are you tied, does not actually affect the results of a shot as much as the passing structures do. So I think there's a lot of promise to this. This is my first ever model building something like this, and I want to continue to build on it. I think by modeling specific teams throughout a season, you can identify their weaknesses and strengths in their game and identify how they attack. By adding some more temporal and spatial parameters, you can even get more accurate predictors. Say by breaking the game into aspects of 10 minutes, you can tell when a team attacks, how they attack. And in general, I think if you apply the math state modeling, which is that say you say that I want to look at my model when when my team is winning by 2 goals, you can actually get a lot more information about how the other team might be attacking you or how they might be vulnerable in this state. So these kind of applications, I think, are really beneficial for decision makers and can allow us to see plays like this. Yeah, that's pretty much it, and I hope I can see more of that. And real quick, just thanks to all the analytics guys for fitting my schedule. Really appreciate that. And yeah, I learned a lot with this. Thank you.